Welcome to part 3 of the Module 10 Statway videos. In this last video, we're going to be looking at independent samples. Now, in the last video, we looked at paired data. That's where you have two sets of measurements for one person. Here, we're going to be looking at independent data, where we have two sets of data but not for the same people. Now in this case, when we're dealing with independent data, the degrees of freedom is not easily calculated like it was in the past. The formula is more complex, so in general we're given the degrees of freedom for the example. Now, if we were to look at a confidence interval, the margin of error is the t-critical value, and again, will be supplied the degrees of freedom. And this is now the formula for the standard error. We have two sets of data, so we have one sample standard deviation and another sample standard deviation. N1 is the number the sample size for the first set of data, sample size for the second set of data. Now, again, we do everything with differences. We get the difference of the sample means for the two sets of data minus the margin of error, the difference of the sample means for the two sets of data plus the margin of error. So let's look at an example here. Alright, so in this first example, suppose you want to estimate the difference between the mean commute time of students at your college and the mean commute time of faculty at your college. To carry out this study, you gather two random samples. One sample is from the students and the other sample is from the faculty. This is independent data. Your samples give you the following sample statistics. So for the students, sample size of 45. For the faculty, sample size of 35. The sample sizes do not need to be the same. Here is your X bar for the students, 35.5. Here is your X bar for the faculty, 46.2. Here is your S, your sample standard deviation for the students, 10.6. And here is your sample standard deviation for the faculty. Now we're going to want to construct a confidence interval. So the first thing is we're going to need the difference of the means. So sample 1, that would be X1 bar is 35.5 minus sample 2, that's the X bar is 46.2, negative 10.7. Okay, we also need S. That's the square root of S1 squared over N1 plus S2 squared over N2. The square root of 2.147. Now here, they tell us the degrees of freedom, 77. It would not be that easy to calculate that for independent samples. You go back to the table, okay, and you're going to find the t-critical value for a 95% confidence interval of 1.991. To get your margin of error, is the t-critical value times the sample standard deviation, 4.28. So, it's the difference of the X bars minus the margin of error, difference of the X bars plus the margin of error, minus 14.98 to minus 6.42. Now, this interval contains only negative values. Thus, it is expected that the difference between the population means is negative. Now, that means the mean commute time for students is less than the mean commute time for faculty. Remember the order of subtraction, students minus faculty. To get a negative mean commute time for the differences, the mean commute time of the first number, students, has to be smaller than the mean commute time of the faculty, which is the second number. Okay, and then the very last thing we're going to look at in Module 10 is hypothesis testing for independent sample data. Now, your alternative hypothesis, this is going to look very similar to what you did for two populations when we were in Module 9 with proportions. Okay, you could have the difference of the means less than 0, which could be written like this, or difference of the means bigger than 0, which can be written like this, or the difference of the means not equal 0. This is the two-tailed test, which could be written like this. The null hypothesis is always that the means of the two populations are equal. Imagine a community college math department uses the same final exam for all college algebra students. The department chair is concerned that students in online courses do not do as well as students in on-site courses, that is, students that are in the classroom. The fundamental or basic research question here is, do students who take online courses perform poorly by comparison to students in on-site courses? The instructor takes a random sample of 40 on-site students and 35 online students. She finds the final exam score for each student in the random sample. Now, the mean score for the on-site students is 75 with a standard deviation of 12. The mean score for the online students is 72 with a standard deviation of 15. Now, conduct a hypothesis test at the 5% significance level to determine if the mean score for all on-site students is higher than the mean score for all online students. Now, if the first population is the on-site and the second population is the online students, if the on-site students are doing better, then the difference of the means is going to be bigger than 0. And for the null hypothesis, we're going to have mu1 equals mu2, or mu1 minus mu2 is 0. Now, looking at the data here, the difference of the sample means 75 minus 72, which is 3. Now, in order to get the t-value, in this case, it's x1 bar minus x2 bar, minus the difference of the population means. Now, we're assuming from the null hypothesis the difference of the population means is 0. So this term is 0. It goes away. And here's our formula for standard deviation. So, using the data they gave us, the difference of the means is 3. Okay, the difference of the population means is 0. Here we have the sample standard deviations that they gave us right over here. Okay, standard deviation of 12 and 15. And here we have the sample sizes. And we get a t-value of 0.95. Now, they tell us that in this example, the degrees of freedom is 64. Again, it would be hard to compute. So, this is a right tail test. So, the p-value is TCDF, 0.95, comma 1E99. They tell us the degrees of freedom, 64. The p-value is 0.173. That's higher than the alpha, the significance level of 0.05. At the 5% level of significance, there is not enough evidence to conclude that the difference in population means is greater than 0. Therefore, the department chair cannot conclude that the online students do worse than the on-site students. And that is the end of Module 10.